Hi everyone, today we're going to be learning about special parallelograms. So we're going to start off with a review of parallelograms that we learned on the first lesson for this chapter. But the definition of parallelogram says that both pairs of opposite sides are parallel. So what you would be looking at would be a parallelogram with both pairs of opposite sides parallel. So that would be parallel to that side, and that would be parallel to that side. Parallelogram theorem, which is biconditional meaning if and only if, but both pairs of opposite sides are congruent. So that means that if you had a parallelogram, this side here would be congruent to this side, and its opposite side would be congruent to its opposite side. Next, both pairs of opposite angles are congruent. So we have this angle being congruent to this angle here because they're opposite. We have this angle here being congruent to this angle here. Diagonals bisect each other. So again, parallelogram. Bisecting each other, this was a tricky one because a lot of people tend to think that the diagonals are all equal. And what it really means is that this, once they're bisected, this line segment here that cuts this segment into half, this segment here also cuts that segment in half, but it makes that equal to that, but it doesn't make them all equal to each other. And lastly, if you have a parallelogram has one pair of opposite sides, both congruent and parallel. So I'm going to draw two shapes to show you for this problem. One pair of opposite sides is parallel, and at the same time, it's congruent. I could also have said this side is parallel to this side, and one side congruent to one side. So if you have a parallelogram is going to have all of these qualities. And so we're going to today talk about some special parallelograms. We're going to first warm up and try to define whether or not these shapes are parallelograms. And in doing so, you might want to hold the video for a minute, go through these and try to figure out what you think, if they're parallelograms or not. So I would look at this and I would say, for this first one, this is 8, it's congruent to 8. 12 is congruent to 12. So this would be a yes, because I have both pairs of opposite sides are congruent. For this problem here, we have 9 congruent to 9. So I have a side, a pair of sides congruent, and I have also a pair of opposite lines parallel, which are the same. So this one would also be a yes. For this problem here, we have an opposite side congruent to an opposite side, and we have congruent sides my diagonals are bisected on one side. This would be a definite no. For this one, we have both pairs of diagonals are bisected. That would be a yes. For this problem, we have both of these angles equal to 70. So we have one pair of opposite pair of angles congruent. But if you remember, the sum of the angles of a parallelogram, or a quadrilateral anyways, is 360 degrees. So if I were to subtract 140 degrees, I would get 220 degrees. Now, I don't know which one. It doesn't say that these are congruent. So let's say this is 200. Well, degrees, not really. But we could just say, let's say this is 100, and we're going to say this one is 120. We don't know that those are congruent. So therefore, if we don't know that those are congruent, you're going to say no. This quadrilateral is not a parallelogram. For this problem right here, we do know from the previous problem that these two add up to be 140, and they're already congruent, opposite sides congruent, or opposite angles congruent. But we also know that the balance of the angles is 220, which would actually make that 110, which would then make both pairs of opposite angles congruent, which would be a yes. For this problem, this also would be a yes because you have a pair of opposite sides are parallel. What this does is this gives me opposite sides. This line right here also gives me these angles that, and there's my transversal. These angles are supplementary, which basically means they're both, if this is right, so is that. It also means the same thing here. If that's right, that's right. So now I have a parallelogram. This quadrilateral is a parallelogram because both pairs of opposite angles are congruent. For this problem, we only know that this angle is congruent to this angle, which would then make this side parallel to this side because alternate interior angles, congruent alternate interior angles form parallel lines. But that would make opposite sides parallel, but not one pair of opposite sides parallel and congruent. These are opposites. So that would be a no. And lastly, this shape right here, you have opposite angles congruent. Those are alternate interior angles. That makes those parallel. And these are parallel, which makes those parallel. So by the definition of a parallelogram, quadrilaterals that have both opposite sides parallel are parallelograms. So what I would do, I have a few theorems that involve parallel lines, so we're going to go over that. If two lines are parallel, so I'm going to draw two lines that are parallel, okay, then all points on one line are equidistant from the other line, meaning this distance is going to be the same as this distance here, which is going to be the same as that distance here, as long as the lines are parallel. And I would use something like that. If I said, let's say that was x, and this was 10, x equals 10. You could say this is, 3x minus 7, and we don't know what that is. You could say x equals 3x minus 7, and then you would solve that equation. So that's something you can do with that. Next, another theorem states that if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So basically, they're saying, here's a parallel, parallel, parallel. Okay, these are all parallel. I'm going to put my little parallel signs in there. If I have three parallel lines cut off congruent segments on one transversal, so what they're saying is that's congruent to that. If that's the case, and let's say I draw another transversal, then they cut off congruent segments. That segment is congruent to that segment. A very important thing to remember is that this segment does not equal this segment here. Okay, those are different. So what you would do with something like that is maybe say these are threes or any number, and to show that they're congruent. And I might say that this is 2x plus 3, and I'm going to say that this is 7. And of course, these are not equal to each other. Please don't make these equal to each other. They're not. That's not what the theorem is saying. The theorem is saying that if the parallel lines are congruent here, that if the lines are parallel and the transversal creates congruent segments on one side, then another transversal will also create congruent segments. So I can say that 2x plus 3 is 7, 2x is equal to 4, and so x equals 2. That does not mean that these are equal. It means those are equal. Practicing once more, we know all these segments are congruent based on, they're all 8s. And then we know that all these are congruent. Now, I can say that I'm going to set this here equal to this, and they're all equal, of course, but I'm going to say 3x minus 7 is 11. I get 3x is equal to 18, and then we get x is equal to 6. So we have that value here. If x is equal to 6, that's right here. And so you have 5 times 6 minus y is equal to 11. So we know this is 30. So we're going to subtract 30 from both sides. And let's see here. So we have negative y is equal to 30. So let's see, minus 30, subtract 30 from both sides. So we get what, negative 19. So y is equal to 19. So now I have x and y. For this problem, the line that contains the midpoint of one side of a triangle and is parallel to the other side passes through the midpoint of the third side. So what that means is basically you've got, let's see, I want to draw that first. So we have a line that contains the midpoint of a triangle. So here's my triangle. And a line that contains the midpoint of one side of the triangle. So let's just draw this line going across like this. What it's saying is if this is a midpoint, of course, that side equals this side. It needs to be parallel to the base. Okay, now if that's the case, if you have your line going through the midpoint and it's parallel to the base, what this theorem is stating is that this becomes a midpoint, and they are not congruent to that, but they are congruent to that side. Now, of course, there are special cases where they would be congruent, and that would be if they were, maybe it was an isosceles triangle or something. Okay, let's see. It's parallel to that. Okay. Let's see what this, this is the same thing. What you would do with this then is possibly say, well, if this is 5 and this is 5, that does show congruence. You see the parallel lines. You might say, well, that's 2x plus 1. Here's 3. So we know that 2x plus 1 equals 3. 2x is equal to 2. X equals 1. One thing about this is that this line actually has a name. And this line that has a name is called a mid-segment. Okay. And if that's a mid-segment, not only are these equal, but this value here is doubled down here. So if this was, let's say, 8, then this would be 16, this length. So this talks about the mid-segment theorem, which I was just talking about, and a segment that joins the midpoints of two sides of a triangle. So let's draw it like this. We have, it joins the midpoints of two sides. So that equals that side equals this side here equals that side there. These are parallel, okay? What that means is that if this angle is, or this length segment is equal to 10, this is now 20, it's double. And this length here, which is my mid-segment, because the theorem states that if the segment that joins the midpoints of two sides of a triangle is parallel to the third side, check, then the mid-segment here, that's the mid-segment, then the mid-segment is half as long as the third side. So therefore, that's half as long. Working some of these out. So here's some fun problems to do. So the first problem, you would, let's see here, let's make these equal to each other, because basically this is saying the segments joins the midpoint. So therefore that's equal to that. Therefore these are parallel, and that would make those equal. So you would say 4y plus 2 is equal to 7y minus 7. Subtract 4, we get 3y. Add 7, we get 9. So y is equal to 3. Okay? For the next part of the problem, you would, for these are your mid-segment there, and so you would say, now people do this differently, and so you have to decide, would you rather say 2 of these is equal to 1 of these, or would you rather cut this in half and say it's equal to that? So that's up to you. I'm going to say 2 of those, which is 3x plus 5, is equal to one of these, 12x minus 8. I know I ran out of room, so I'm going to continue this over here. 6x plus 10 is equal to 12x minus 8. Subtract 6, I get 6x here. I'm going to add 8 to this side, I get 18. So I get x is equal to 3. For the next problem, we know these are congruent. And again, I don't know if you could see that. It's pretty small. But what it says is, I believe that says x squared plus 6. Let me make this a little bit bigger. Let's see. Maybe. Nope, not making it bigger. What this says is I'm going to have 2 of x squared minus 6 is equal to 1, 5x. So I'm going to distribute, because I'm not going to divide by 2, because that's going to give me a fraction here. I don't want that. So we're going to have 2x squared minus 12 is equal to 5x. So one thing you're going to do when you're solving this problem is that you're going to realize that it is quadratic, and what you should be thinking is that quadratics need to be set equal to 0. And that's the first thing that you need to do. So you've got 2x squared, subtract 5x, minus 12 is equal to 0. And when you're rewriting these, always put them in descending order. So starting with the x squared, then the x. We're going to factor this. You are allowed to use the quadratic formula if you choose to. Go ahead. We have 2x times x. We know that one of our terms, in order to get negative 12, one of my values has to be positive and the other is negative. In order to add to 5, these two values here, after they're multiplied, need to be negative 5. So my choices to multiply to be negative 12 are respectively 1 times 12, 2 times 6, and 3 times 4. So one of my values is going to be like that. And of course, one will be positive, one will be negative. I'm going to start off by choosing 2 and 6. So I'm just going to choose 2 and 6. You're going to check it. You check the insides and you check the outsides. You've got 2 times x is 2x, and 2 times negative 6 is negative 12. When I add those together, I get negative 10x, which is not what I want. I want negative 5x. So what that means is this number is incorrect, and then we're going to rewrite it. And normally, you're going to flip-flop them. Now, what we did, I believe I said that was 6 here. So now I'm going to put 6 here, and I'm going to put 2 here. Check the insides, check the outsides. You get 6x, and then you get negative 4x. Well, that's 2x, which is still not right. I want negative 5. And so I'm going to rewrite this again. I'm going to choose another number. And this time, I'm going to choose, so 2 and 6, not going to work. I don't think this is a value because I only want 5. And if I multiply by 12, I'm going to get a pretty high number. So I'm going to try next 3 and 4. 3 times x is 3x. So that's 3x. And then we have 2 times negative 4 is negative 8x, which makes negative 5x. So now we have the right factor. And so what we're going to do now is we're going to split the answer up like this. We're going to get x minus 4 equals 0, x equals 4, 2x plus 3 equals 0, 2x equals negative 3, x equals negative 3 halves. And for this problem, I have 2 answers, and you're allowed to have 2 answers. But one thing that you should know is that you cannot have, while you can have 2 answers, but you can't have negative lengths. And in this case, see this negative length, negative 3 halves? When I plug this into here, which says 5 times x, that x, when I plug it in, will be negative. And that's not going to work. So I can't have that value. So my final answer is just x equals 4. So we're going to start talking about special parallelograms because remember our flow chart that we did. We said, okay, we have quadrilaterals. And of quadrilaterals, we have parallelograms. We have trapezoids, which are still quadrilaterals, but not parallelograms. And we have kites. which also have four sides, but are not parallelograms. And so for something to be a parallelogram, remember the 5 things that had to happen. They had to have both pairs of opposite sides are congruent. They had to have both pairs of opposite sides are parallel. We had to have both pairs of opposite angles congruent. We had to have one pair of opposite sides congruent and parallel. And then, let's see, what was the last one? Oh, both pairs of diagonals, both of my diagonals had to bisect each other. So in order for something to be a parallelogram, all of that stuff has to happen. And in that case, we had 3 cases that were parallelograms. We had squares, we had rectangles, and we had rhombuses. And those 3 all fell under the parallelograms. So what we're going to do now is I want to talk to you about the special things about rectangles besides it being a parallelogram. So we're going to write it's a parallelogram. That's number 1. And with that becomes 5 characteristics, okay? 2, a rectangle, so let's draw a rectangle. A rectangle not only is a parallelogram, which means, of course, it has both pairs of opposite sides congruent, opposite sides parallel, both pairs, all of that stuff. But what it does is it also has 4 right angles, okay? It has 4 right angles. All right. Now, it also has diagonals that are congruent. So my diagonals are congruent. And what that means, why that's kind of cool, is that remember because it's a parallelogram, the diagonals bisect each other. But if my diagonals are the same length, let's say they're both 10 centimeters, then when I cut it in half, those are 5, those are 5, those are 5. So that makes all the bisections congruent also. So that's kind of cool. So those are the neat things about a parallelogram. Rhombuses, these are one of my favorite. I love rhombuses. A rhombus is pretty special in that, number 1, it is a parallelogram. Okay. Number 2, it does have 4 congruent sides. 4 congruent sides, whereas a rectangle does not. When you look at a rectangle, most of the time you're going to draw something like that, and that doesn't have 4 congruent sides. Now, number 3, a rhombus also has diagonals that bisect the angles that are opposite, that are already congruent. So you can write the diagonals bisect the angles, opposite angles. Okay. And lastly, not only do the diagonals bisect both pairs of opposite angles, but the diagonals are perpendicular. So the diagonals are perpendicular. Okay, so that's really important. So one of my favorite things is the rhombus. The next very special parallelogram is a square. And a square, squares are have superpowers because they just have about everything. So let's say there's our square with hands and feet. And of course, what kind of a superpower does have a cape? There we go. All right. So basically, our square is all powerful. Okay. And that is because, number 1, not only is it a parallelogram. Okay. Number 2, it does have 4 congruent angles, just like a rectangle. So 4 congruent angles. Of course, those angles are all 90 degrees. Just like a rectangle, it has congruent diagonals, So you would say congruent diagonals. Number 4, just like a rhombus, it has 4 congruent sides. All the sides around are congruent, okay? And also, like a rhombus, the diagonals, DIA, the diagonals bisect the opposite angles. And just like a rhombus, the diagonals are perpendicular. Now, every single characteristic that a rectangle and a rhombus have, a square has all of that. And so that makes a square everything. It makes a square is a rhombus, a square is a rectangle. But a rectangle can never be a square, and a rhombus can never be a square. So a couple of just things about our special parallelograms. A rectangle is a quadrilateral that has 4 congruent angles. Okay. A rhombus is a quadrilateral that has 4 congruent sides. A square is a quadrilateral that has 4 congruent angles and 4 congruent sides. Therefore, every square is a rectangle, rhombus, and also a parallelogram. And this is just a little side note on the bottom. Since rectangles, rhombuses, and squares are parallelograms, they all have the properties of a parallelogram, all 5 of them, always. So more theorems. We have the diagonals of a rectangle are congruent. So we've already talked about this. The diagonals are congruent. They have the same length. The diagonals of a rhombus are perpendicular, okay? Each diagonal of a rhombus bisects the 2 angles of a rhombus. And if one angle of a parallelogram is a right angle, then the parallelogram becomes a rectangle. So let's say that again, because I think I said that too fast. If one angle of a parallelogram is a right angle, if one angle of a parallelogram is a right angle, one angle, and it's a parallelogram, which means that both pairs of opposite sides are parallel, then the parallelogram is a rectangle, and the reason is because you have same side interior angles that are congruent, which makes them parallel, which makes them congruent, and then you have 4 pairs of that. But I did want to go back to this one, number 3. While the diagonals of a rhombus bisect the angles of a rhombus, the diagonals of a rectangle do not bisect. They don't bisect the right angle here. That is not bisected. The only ones that are bisected are the squares. So for example, if you had a square with a diagonal like this and you know it's a square, then each angle here is 45 degrees. But that doesn't work on a rectangle. So we're going to do a few practice problems. So let's get started on that. This one right here says, let's see, solve for x. So these values here look like all midpoints. So therefore, we have mid-segments. There's a mid-segment. There's a mid-segment. This value here, 2 of those makes 1 of those. So 2 times 10 is equal to 2x plus 12. We have 20 equals 2x plus 12. Subtract 12. We have 8 is equal to 2x. X equals 4. Okay. Solving for z, we know that gm is z squared minus 3. We know that RA is z minus 1. So that means z squared minus 3 is equal to z minus 1. You should notice that that's a quadratic. We're going to subtract all values and set it equal to 0. So we have z squared, bring the z over, minus z. I'm going to add 1 to both sides. I get minus 2 is equal to 0. I'm going to factor that, and I'm going to get z minus 2 times z plus 1 is 0. And check that. I get -2 plus 1 is -1. I'm going to split this up. I'm going to go z plus 1 is 0. So z equals -1. Z minus 2 equals 0. So z is equal to 2. Make sure that both of your answers work, so you should plug them in. If you plugged in 2, you get 2 squared, which is 4. 4 minus 3 is 1. Plug in 2. 2 minus 1 is 1. 1 equals 1. We're good. So this is an answer right here. Plug in -1. If I plug in -1 squared minus 3, I get a negative number. Not going to happen. A couple more examples for these problems. We know that Fy is, the whole thing is going to be W plus 21. We know that Fe is 2W, and if these are midpoints, then they're both midpoint. Well, I know it's a midpoint because this is congruent to this, and those are parallel. So that's also 2W. Find W. So it looks like we have 4W. So 4W's is equal to W plus 21. Subtract W, you get 3W equals 21. W equals 7. Okay, solve for Y. These are congruent. And I would say on a test or a quiz or something like that, most of these are going to have numbers here and or congruent signs to just throw people off, because a lot of people will say 2y is plus 3 equals 10, but that's not the case. If you have congruence here and here, and these are parallel, that makes this congruent to this, but it does not make them congruent to each other. So your only option is to say, and I think I can't see that. Oh, that's a 2. Your only option is to say that 2y, let's see here, 2y plus 3 is equal to 3y minus 5. So I'm going to subtract 2y from both sides. I'm going to get y. I'm going to add 5. I get 8. Y is equal to 8. So just in closure, you should, I would do this. I would practice, number one, I would practice drawing the 5 or the definition plus the 4 theorems. I would draw the 5 characteristics of a parallelogram. And I would keep drawing, I would write the characteristics or properties of special, square, rectangle, and rhombus. And then just practice in as much as you can. Well, I hope that helps. Thanks for watching. Thank you.